Okay, my Algebra 2 folks, just a kind of a quick video to kind of summarize what you guys are already watched for section 12.1. Kind of just maybe putting things in some different words, maybe that might make life a little easier for you, or clarify some stuff as we go. So as we go through and look at this right angle trig stuff, um, right triangle trig stuff as we look at. You guys should remember this from geometry. This happened last year. Some of you had it last trimester, even a couple of you are doubling up. So just remember right triangle trig, first of all. We're dealing with this idea of SOHCAHTOA, and we're dealing with three main functions. Okay, we call them the sine function, we call them the cosine function, and then we call them the tangent function. Okay, and they each have this, and that's where this SOHCAHTOA comes from. All right, so it's just to remember it all deals with opposite, adjacent angles. So if you look at what each of these are, each of them has an O or an A, or even it goes a tangent, both. Okay, the H stands for hypotenuse. Hypotenuse. Wow, I didn't spell it right at all. Hypotenuse. I think that's how it's spelled. Good. Hypotenuse. All right. So as we look at this, each piece just deals with the relation to the side of a triangle. All right. And what people screw up more often than not is this opposite and adjacent. Okay. And so first thing first, locate your angle. Okay. Here we're going to call it theta. That's just kind of the mathematical term for that. It could be an X, could be a Q, could be a letter. Doesn't matter. It could be A. All right. But just the idea of that's the location of your angle. We call it our reference angle. That's what we're looking at. So opposite versus adjacent. And that's the one that gets people more often than not. And how you remember that is the opposite side is the part that does not form the angle. The adjacent side forms the angle. So you probably want to write that down in your notes. Let me say it again. The opposite side does not form the angle. The adjacent side forms the angle. Okay? So if I look at this particular triangle in general, okay, so sine, cosine, tangent, so OH is the opposite side over your hypotenuse. Cosine A is adjacent, so that's the adjacent side over your hypotenuse. Tangent is O and A, that is the opposite side over your adjacent side. Okay? So looking at that as we go through, we can get that from the pretty simple and just make a fraction. Okay, so the sine of theta here is equal to, that means they have the same value, they're interchangeable, opposite. Now, if we look at this, here's my angle, and if I kind of go over this in blue and red, there's the sides that make the angle. Okay, the hypotenuse is always the longest side. That makes it easy for us. So if I want to know the opposite, the one that doesn't form the angle, well, these two sides form my angles. The one that doesn't here is A. The one that the hypotenuse, longest side, there's C. So that would be the value of the sine of that particular angle. And notice it doesn't give me an angle measure. We'll talk about that here in a minute, but that's just how we set this up. So cosine is the adjacent over the hypotenuse. Your adjacent side is the one that does form the angle. So again, in red here, gone over a bunch of times now, those are the two sides that form an angle. The adjacent is the side that forms my angle. So that is B, and my hypotenuse again is C, the long side. And then tangent is the opposite over the adjacent. Opposite doesn't form the angle. That's this guy hanging out over here, A. The other way to look at this is you look how the angle kind of opens up to A. So there's the angle. The side that's open on is A. And then the adjacent, again, is B. So that's your basic three right triangle trig functions. What is the sine of this angle? Make a fraction. What is the cosine? Make this fraction. What is the tangent in this side? So that's SOHCAHTOA, opposite versus adjacent. Now, I'm going to kind of take a little detour here and talk about reciprocal really quick. Okay, reciprocal is just what it says, the reciprocal. And we have different terms for the reciprocal function. So let me move these guys over. Each one of these pieces has a reciprocal function. Sine's reciprocal, and I'll put that over here. Okay, reciprocal just means flipped. Sine is called cosecant. We do CSC. Okay? And that, again, instead of being the opposite or for the hypotenuse, it is the hypotenuse over the opposite. Okay? Cosine is actually something called secant. Now, why they call this cosecant and this secant, I really don't know, to be honest with you. You can Google it and find out. But if to keep them straight, this one has an S, gets changed to C. Okay, reciprocal, flip it. So flip the S to a C, flip the C to an S. That will help you remember. This will be a hypotenuse over your adjacent. And then tangent is something called cotangent, or just COT. Okay, that will be your adjacent over your hypotenuse, or opposite, excuse me, not hypotenuse, opposite. Okay, so reciprocal just means flipped. Okay, we're not changing anything. We're just flipping the fraction we have. And those are pretty easy to find. Now, some words of warning. Okay, with reciprocal here, okay, you might need to rationalize your denominator. Because sometimes when you flip, you have a square root in the top of your fraction. You might need to flip that to make it, to rationalize it so it works for you. So keep that in mind. All right, so that's reciprocal. Your special triangles. Let me get rid of all the ink here, and I will kind of take this here. All right, so we had 30, 60, 90, and 45, 45, 90. So if we do a 30, 60, 90 triangle, and orientation doesn't matter, just matters where they are. Okay. Now, the nice thing about a 30, 60, 90 triangle, you can start out with the small angle. Okay? The side opposite this, the small angle is always 30. The side opposite that is always going to be x. Okay? And how you can kind of tell is they're all going to have something to do with x. But in the long run, you have to figure out what each piece is. So x is the smallest. Now, if I change that, my hypotenuse will always be twice that length. Okay? So that's a relationship always. The small side, the hypotenuse is always double the small side. And then my last one will be x, x, and then the square root of 3. Now, why is that? Well, we can kind of actually do a quick little side step here. If I take this guy out here, if we did not know that for a second, we have Pythagorean theorem, if you remember. So, a squared plus b squared will equal c squared. If I look at all that, a squared is x, so it'll be x squared. I don't know what b squared is. And this is kind of how we derive all this stuff, but I know c is 2x squared. We'll break this down. This is x squared plus b squared will equal 4x squared. Okay, well, if I subtract x squared from both sides, I will have b squared equals 3x squared. Take the square root of both sides. I'll have the square root of 3 times x, bring him out front, x squared is 3. That's why in a 30, 60, 90 triangle, the 60 degree is always x squared to 3. Okay? All right, so that's 30, 60, 90. The other one is the 45, 45, 90. And you get the side lengths because of the same way. So if I bring out another right triangle here, here's a 45, 45, 90. Okay? And the idea here is because these two angles are equal, these two sides are going to be equal as well. And if you go through the Pythagorean theorem once again, you'll find out you get x and then the square root of 2. So if you know a side length, you can set it equal to these generic ones, and you can find the value of x, which will help you find the value of everything else. So it's just a matter of solving for a radical, squaring things and taking care of it in that way. Okay, so those are my special triangles. We got SOHCAHTOA done, special rectangle, we took care of reciprocal, inverse. Okay, last piece here. And again, I'm going kind of quick, but you should have already had stuff taken care of from the video. So if you haven't watched the videos from 12.1 yet, you need to go do that first, or else this might not make a lot of sense. All right, so inverse. Okay, inverse we use to find an angle measure. Okay, so what an inverse does is it switches the angle value and the function value. Okay. So what I mean by that is inverse. If I had sine of theta equals a over b, let's say, you have some idea here. The inverse will switch these two pieces around right here. So if I take the inverse of either of them, what happens is now I have a over b, and that's going to give me my value of theta. Okay, so if you know the value of an angle, let's say you don't know the value of, you want the sine of theta will equal, let's say you know it's 0.75. Let's say you know that to be true. It's given in a problem, whatever you have, you know it's true. You can find my value by simply doing the inverse sine of that value, 0.75, and that will equal theta. Okay, and something in here is make sure your calculator is in degrees. Okay, you go to the mode menu to do that. You'll find that there. Okay, so as you do that, if you know what the value is, you know you did SOHCAHTOA, you found all that stuff, you found the fraction value. If you take the inverse of that fraction, you will find out what the actual angle measure is. Okay, so that's that piece. All right, good. Last piece: angle of depression versus elevation. Okay, elevation, you are looking up. Depression, you are looking down. Okay, so you have to think of it kind of as of how you're looking at it, and set your triangle up in this way. So if you're talking about elevation, okay, and we're going to use my wonderful drawing skills to look at this. So if I take elevation and we find little Mr. Gembus is sitting right here. Okay, so there's Mr. Gembus. You know, he's a cool guy. Okay, elevation, you have sight straight out, and then you're looking up at an object. Okay, so if you notice, it creates a right triangle that way. But the key in the difference in both these is where theta is. Okay, it's all based on this horizontal piece. Okay, so the horizontal piece, the horizontal part forms what you're looking at. Okay, elevation, remember up, right? Okay, and look where theta is. It's above the horizontal. So your angle, theta, is above the horizontal part. Okay, so that's very important. And we're going to use tangent. Okay, most time, 99.9% of the time, you use tangent because you'll have distance from yourself to the object and then the height of the object. Just keep that in mind. You might use something else, but more times than not, you're going to use tangent. So keep aware of that. Now, depression, again, we're looking down. So if I'm now, let's say I'm up here on a cliff, there's Mr. Gembus again, you know, cool guy Mr. Gembus here, you know, your favorite math teacher in the whole world. Here's an object. Let's say there is, I don't know, a dog. Coolest dog, maybe a cat. We'll call it it's a lion, or I don't know, what is a zebra. Okay, it's a dog. There. Okay, I'm looking down at that. So again, I have the horizontal. Okay, and then I'm looking down. There's my line of sight. I'm looking down at whatever this filthy animal is. Okay, laugh at me all you want. And again, theta now is here. Okay, it's below the horizontal. Okay. So that's going to be the difference there. Elevation, it's above the horizontal, theta is below. Again, you're probably going to use tangent to get it all figured out and work through it. So that gives you an overview of what we did in section 1. If you haven't watched the 12.1 videos yet, you're going to really want to go back and watch those. Get the key concepts down along with the videos, the video notes that go along with them, or else you're going to be completely lost. But that's what we're looking at today. Go through a lot of it should be review to give you a good start here on the trig chapter as we go forward. So have a great day, be great, and I will see you on Wednesday.